Hello, and welcome to this lesson on two-way frequency tables. This is the other data display we're learning about in this unit. Our essential question says, how do I read and interpret two-way frequency tables? Okay, so that's our job, to be able to read, interpret, and even make a little bit. For the warm-up here, it says just list all the ways you know of to display data. Can you think of all the different data displays you've ever learned about and make a list of them? Some things you might have come up with. You might have come up with a bar graph, a line graph, a stem and leaf plot, a box and whisker plot, a frequency table, a circle graph or a pie graph, a dot plot, or a number plot. Those are both kind of the same thing. There's also like the double bar graphs and double line graphs. Scatter plot is one we just learned about in the previous few lessons. Well, this is another one. This one's called a two-way frequency table. The vocabulary we have here is, well, sort of old and sort of new. We know what bivariate data is. Bivariate data is data involving two variables. It's the same sort of thing as the scatter plot, involved two different variables. Now, a two-way frequency table is a table, or it's a chart, that shows the frequency of each category. And that makes zero sense right now. You'll see it when we actually look at an example here in a minute. It'll make a lot more sense. And the last vocab word is the relative frequency. The relative frequency is a ratio of the number of times an event occurs to the total number of events. It's usually shown as a percentage. Okay. That definition, if you know what probability is, that definition is actually very, very similar to the definition of probability, how often something occurs over a total number of events. So it's very, very similar to that same definition. And again, we'll make much more sense of that when we actually get into the lesson and have to do it. So this is what a two-way frequency table looks like. It's a big old chart with, we've got units on the top, units on the side. Here it says the table below shows the favorite sport for each school in a small school district. So we can, just looking at this, things we could figure out, like 20 kids in elementary school like basketball. So this 20 is the elementary basketball people who like that. This 50 is middle school football. So there's 50 kids in this middle school that like football. I can see that there is 125 total people that like football, because that's right here. It's this row and column. Okay, so just looking at the table, we can find certain numbers, and we may be asked to do that. Just, well, how many kids are in high school? Well, 145, stuff like that. So right now, like, how many middle school students were surveyed? So just how many total middle school students were surveyed? So we go to the middle school, that's here, and we go down until we find a total. Total, 118. Done. Now, there won't always be a total, so sometimes we would have to do the extra step of actually adding the total. Second question says, how many elementary students like baseball? Okay, so we go to elementary students, baseball, and they intersect here at the number 53. 53 elementary students like baseball. Fairly straightforward. Same table, just there's more questions and it was too much to fit on one page. Now this question's quite a bit more challenging. It says, is the percentage of middle school students that like football higher than the percent of high school students that like football? Ooh. So now we're being asked about percentages and two different schools and whether they like football. So I'm going to kind of organize my problem. So I'm looking for the percent of middle school students that like football. That's what I'm going to find over here. And then I'm going to find the percent of high school students that like football. So let's do one at a time. So middle school. I'm going to highlight the middle school in blue. I lied. I'm going to highlight the middle school in red. So I have in my middle school, what is the percentage of middle school students that like football? My total number, when I'm trying to figure out my percentage, I know there's a total of 50 middle school kids who like football. But how many total middle schoolers are there? Of the middle school students, that's my big number. The denominator, the fraction, the total of everybody. Of the middle school students, well, how many middle school students are there? There are 118. So that's middle school students, the middle school students that like football. Now, this fraction can be simply just divided and we can get a percentage. So 50 divided by 118. Actually, I lied. It gives us a decimal first, and we'll change the decimal to a percent. So that is 0.42, which is 42%. You move the decimal over 2 places, or you can multiply by 100. Both of those are good methods. And we get 42.37 blah blah percent. I just chopped off the decimal part. 42%. Now for high school, we're going to go through the same process. Now the high school, I'm actually going to highlight in blue this time. So I'm looking for the high school students that like football. Now I can see that 60 high school kids like football. But out of all the kids, of the high school students, the of number is your denominator. Of the high school students, of the 145 high school students, how many of them like football? Well, 60. So 60 out of 145 like football. And then I'm going to go through the same process. I'm going to take, 60 divided by 145 gives me 0.413. When I move my decimal over 2 places or multiply by 100, I'm going to get 41%. So now we're actually ready to answer the question. Is the percentage of middle school students that like football higher than the percentage of high school students that like football? Is this percentage, middle school, higher than the high school percentage? Yes, is our answer. The middle school, there are more middle school students by percentage that liked football than high school students, even though the number was lower. Okay, new problem. The graph below shows the results of a study to see if students like playing a musical instrument and like playing video games. Make a two-way frequency table. All right, so here's how I start pretty much all my two-way frequency tables. I start by making a tic-tac-toe board. Don't make it too big. You need space all around it. I then take my tic-tac-toe board and I draw a box around it. Inside here is where all my numbers are going to go. On the outside is where my labels are going to go. So you need space on the top and on this left-hand side. You really actually don't need any space on the right-hand side, but that's okay. So what things are being measured according to this table? The little Venn diagram we have here. Well, we have people who like playing music, people who like playing video games. But what else? Like, do I put like music here and video games here? What would go over here? Well, actually what we're going to do is the video games I'm going to put on the top. I could just as easily put it on the side, but we just have to put it somewhere. Okay, so it really doesn't matter which one goes on the X or the Y side. So I'm going to have people who like video games. So VG, video games. And people who do not like video games. Because there are going to be people here who don't like video games. These 7 people don't like to play video games. I need to have some place for those people. On the other side, I'm going to do the same thing but with music. So I'm going to have my music people and my not music people. And then what goes in this last spot? Well, that is the space for our total. I always recommend you to have a space for your totals in your two-way frequency tables. Even if you have to make it yourself, if you have to add a row and a column onto a table to find your totals, I highly recommend that. It is very, very helpful. All right, so here's what I want you to do. I want you to take a second and I want you to see if you can figure out where these four numbers go in our two-way frequency table. Take a second or two, pause the video, try it. Think about it. Even if you just want to think where you think they go, think about it, and then hit play, and then we'll go through it together. All right, so these 13 people, those 13 people like to play video games because they're in the video game circle, and these 13 people like to play music. So where in my table do I have a place for people who like video games and like music? It's right here, this spot. They like video games, they like music. That's where they go. Okay, these 11 people. Actually, let me go back to blue. So here's my blue 13. All right. So those 11 people here now, my pink color. These are people who like video games, but they do not like playing music. So I'm looking for people that like to play video games. So in my table, okay, here's people that like video games, but I need like video games and they don't like music. Like video games, but not music. So right here's where my 11 goes. They like video games, but they don't like music. These 7 people are the opposite. These 7 people like to play music, but not video games. So they like music. They're in this row here. They like music, but not video games, which puts them in this spot. So those 7 people like music, but not video games. Oops. Need a new color. Green. All right. These 9 people down here, they are not in any group. They are not in playing music. They are not in playing video games. Those 9 people don't like either thing. So where do they go? Well, is there a space in our table for people that don't like music and don't like video games? There is, right here. Not music, not video games. It is right here in this intersection. So right here is these 11 people. Oopsie, not 11. Try it again. 9 people. Okay, so I've highlighted where each of the colors go so you can kind of make the connection between what it looks like in the Venn diagram and what it looks like in the table itself. The last thing we need to do now is just fill in our table. Do we know how many total people like video games? Yeah, it's 24. We could do this one of 2 ways. You can go, well, how many people are in the video game circle? 11 and 13 makes 24. Or you could go, the total video gamers is these 13 plus 11 is 24. The total people who do not like video games, I've got 7 and 9 gives me 16. Do not like video games. Total people that like music, I can do my sum across here is 20. That is 13 plus 7 is 20. And I can do my sum for the people who do not like music, and that is also 20. And then finally for my total. This total should be the sum of this, which is 40, and this should be the same. If it's not the same, you messed up. All of these numbers should add up, down, left, right. Everything should match up. This number here is the sum of these two, 40, but it's also the sum of those two. 24 plus 16 is 40. No, I'm not going to make this 80. I don't add the 40 here and the 40 there to make this 80 total. No. Okay, so it should just be this math should add up. This math should add up for all 3 rows. 13 plus 7 is 20. 11 plus 9 is 20. 24 plus 16 is 40. Check. 13 plus 11 is 24. 7 plus 9 is 16. 20 plus 20 is 40. check. All my ups and downs and lefts and rights all add up properly. Oh, that's all we had to do. I was hoping there'd be some questions, but I guess not. Okay, so that's just making a two-way table. You should be able to do that. Okay, now that you've seen the process, it's not so bad. And there are times where maybe this original, when we did the tic-tac-toe board and we put a box around it, maybe that's not big enough. All you need to do then is just, if you needed to, add another row or add another column, and you can make your table as big or wide as you need. If you had 3 different variables or 3 different things, you would put them around here and then add another row for your totals. Okay, so that's how you can expand it quite simply. Letter C. A coffee shop did an informal survey of their customers' drink buying habits one day. The results are shown in the 2A table below. The owner wants to be able to better serve his customers. Of the customers surveyed, what percent ordered hot drinks? So that's your question. Of the customers surveyed, what percent ordered hot drinks? So I would like you to pause the video, and I would like you to try this problem. It's a little bit harder than you think, but maybe also not quite as hard as you imagine it could be. So take an extra minute or two if you need to, especially if you think you're getting stuck. What percent of all the customers surveyed ordered hot drinks? Go ahead and pause the video and do it now. Okay, so one thing's missing from our table. We don't have any totals. So I can add a total column here. I can add a total row here. And that may be helpful. I mean, I personally like to do this no matter what. No matter if I need them or not, I find it helpful. So I'm going to start adding these up. So 20, 40, 50, 63, 28, 38, 41, 46. I should probably use my calculator to double check me because I'd hate to mess up one small thing, but I'm pretty sure I'm right. There we go. That was 46. 26 plus 27 plus 10. See, I'm good. That's 30, 43. Double check it. 15 plus 18 plus 10. And lastly, that is 30, and 30 makes 60. I'm not even going to check that one. I'm pretty confident. Okay, across. I don't think I needed that. There we go. So we've got 30, 40, 55, 58. We've got 22. That one's a little bit harder to do in my head. So I'm just going to calculate with the calculator. And that was 81. And 27 plus 28 plus 10 plus 8 equals 73. And now, if I did all this right, these 4 numbers added together should be the same as these 3 numbers added together. So 63 plus 46 plus 43 plus 60 is 212. The other one was 58 plus 81 plus 73 is good. So I know all my totals added up. I didn't make any weird mistakes anywhere. Now, we didn't actually do all that for no reason. That actually is helpful because we want to know what percent of customers surveyed, which means of the customers surveyed, my total people in my fraction is that 212. Because of all the people surveyed, of all 212 people, what percent ordered hot drinks? Well, that's my total people. So now I need to find how many ordered hot drinks. Well, hot coffee, hot tea are hot drinks. Iced coffee and soda are cold drinks. So the people that ordered the hot drinks would be the hot coffee and the hot tea. Gives me 109. That is this one and this one together. is 109 out of 212. And to find a percentage, we divide. And we got 51.4%. If you don't know how I got that, it was 0.514. You move the decimal over 2 places. Boom, 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 boom. 51.4%. So 51.4% of customers surveyed ordered hot drinks. But we could even ask other questions or answer other questions like, do you see a pattern here on somebody's age versus the drinks they get? Well, yeah. You notice young people that are less than 18, they ordered a lot more cold drinks than hot drinks. Old people ordered a lot more hot drinks than cold drinks. I mean, that's a relation that we could find from the table. That's something a little interesting. It wasn't the question they asked, but that's something that we could figure out from the table if we needed to. Letter D here says, at a school cafeteria, the staff is trying to find out which foods the students like the best. The results are shown in the table below. Construct a two-way frequency table to display the data. So here we have this. So this would be basically a tally chart, right? So I got 6th grade, they ordered pizza and Cougar Bowl. 7th grade, pizza, Cougar Bowl. 8th grade, pizza, Cougar Bowl. Okay? We're going to take this information and we're going to put it in here. So this space here is where we're going to put our two-way table. So I'm going to get you started and I'm going to have you finish up. So I'm looking at this. I mean, I've got 2 foods and 3 grades. So looking at my table, I kind of have to put some of the things in specific places. Like I should probably put my grades across the top because I've got 3 grades, 6th, 7th, 8th, and 2 foods, pizza and Cougar Bowl. And if you're watching this online and you don't know what a Cougar Bowl is, it's kind of like the KFC famous bowl, like the mashed potatoes and the little piece of chicken and the corn and the gravy and the cheese, and delicious. All right, so I got the table starting to set up. I got the stuff labeled. Could you quickly go through, pause the video, and get the numbers in the correct spaces in our table? So make this two-way table right now. All right, so you should have said in the 6th grade pizza, there is 5, 10, 13. In the 7th grade pizza, there is 5, 10, 15. In the 8th grade pizza, there is 11. In the 6th grade Cougar Bowl, there is 9. 7th grade Cougar Bowl, there is 13. 8th grade Cougar Bowl, there is 10, 12. So we've made our two-way table. Now we can answer some questions about that. For example, how many total students were surveyed? You know, this question would be a lot easier if we had our totals. Do you know what I'm going to do? Total. So let's see here. That is 22. That is 28. That is 23. That is, I'm adding this way now. 20, 40, 60, 73. Over here we've got 10, 20, 30, 38, 39. And 10, 20, 25 plus 9 is 34. And does 39 plus 34 equal 73? It does. So we're probably correct. We probably got all of our numbers right. And now, how many total students were surveyed? 73. Easy enough. What percent of 8th graders liked the Cougar Bowl? So of the 8th graders, that is going to be my denominator. Of those 23 kids, you guys, of them, what percent liked the Cougar Bowl? Well, the fraction would be 12 out of 23. 12 out of 23 8th graders liked the Cougar Bowl. So then, as a percentage, I would take 12 divided by 23. and I would get 0.521, which equals 52%. The next question says, what percent of people who liked pizza were in 6th grade? See if you can do that one. What percent of people who liked pizza were in 6th grade? Try it. Pause the video and see what you can come up with. Now, the place you might have messed up is in the denominator of your fraction. You almost everybody probably got, hopefully, a 13 for their numerator. That's the 6th graders who like pizza. Where you messed up might have been the denominator. So it's of the people who like pizza. That's my denominator. The total people who like pizza was a 39, not a 22. It should be a 39 here. Of the people who like pizza, what percent were in 6th grade? And that should give me 33.333333. Good. Let's make a percent. So, I mean, I can see if I divided this in my head, I was going to get 1/3, which is that decimal, which is that percentage. Okay. So this of number tells you what the total number you're looking for. Of the people who liked pizza. Of the 8th graders. That's going to be your denominator. Letter E, and this is the last one. It says, you did a survey of 300 students in 8th grade to see if they like art or music. 30 students don't like art or music. There are 195 students that like music. 125 students don't like art. Fill in the two-way frequency table below. Now, here's what I'm going to ask of you. Instead of filling the entire thing, because there's a chance you'll make a mistake, what I want you to do is I want you to label your table, so the gray boxes here, and then fill in the numbers that are in the word problem. Fill those numbers in your table, and then stop. That way, if there's a mistake, we only have to fix a few numbers, and we don't have to fix a lot of numbers. Once we get those few numbers placed, I'm going to have you recheck the rest of your numbers as well. Okay, so label and put in the numbers from the word problem in your table right now. All right, so this question is asking if people like art or music. So this is kind of like our video game and music problem. So I'm going to have art, not art. Music, not music. And then the extra ones go for my totals. Total. Now you may have put music on the top here and art on the side, and that's okay too. There's nothing wrong with that. They're just going to be flipped. Our numbers will be slightly different places in our table, but it's okay. So things I know that there are 300 total people in this survey. You did a survey of 300 students. That is my total. The total of everybody is 300. Okay. I know 30 students don't like art or music. So I'm going to put a 30 where the students don't like art and don't like music. That's right here in the center. Not art, not music, 30 kids. It says there are 195 students that like music. Now, this is where I have a bunch of students who kind of make a mistake. I get a lot of students who put 195 right here, which is wrong. It does not say there's 195 kids who like music and art. It just says there are 195 students that like music. So this 195 doesn't go here. That's my total kids that like music. There are 195 kids that like music. Total. Doesn't say if they like art or not art. It's just they like music. 125 students don't like art. They don't like art. We know nothing about their music likes or not. It's just they don't like art. So that 125 is going right here. So, if you need to fix up your table, do so now. If your table's good and you plug those numbers in the correct places, awesome sauce. Now what I want you to do is go back and check all those other blanks to see if you did them right, if you did them already, and if you didn't do them yet, pause the video now and see if you can fill in all those blanks on your own, and then we'll check over them together, okay? Go ahead and do that right now. All right, so when you're filling in your table, like there are certain boxes that you literally can't fill in right now. We cannot fill in this box right now. We don't have enough information. I cannot fill in this box right now. There's not enough information. I could fill in each of these other three. What I'm looking for is, I'm looking for a row or a column where I'm only missing one number. For example, right here, I know that this number here, whatever this is, this number plus 30 is 125. This is the total of this row. So if I take 125 and minus 30, I got 95. 95 plus 30 is 125. That's my total of this row. Same thing here. 195 plus something is 300. I know in my head that number is 105. I could subtract 300 minus 195, and I should get the same thing. This one here is the other one we could have figured out originally. For the same reason, I know that this number plus 125 is 300. This is the total of this row. So if I take the 300, subtract 125, I'm going to get 175. But as we're working through that process, as we filled in this number here and we filled in this number here, look at this. Now this row is only missing one number. I have the other two. I know that this is going to be a 100 because 100 plus 95 is 195. I can do that subtraction in my head. Here, this is going to be a 75 for two reasons now. One is this math. 100 plus 75 is 175. But also this math here. 75 plus 30 is 105. So my numbers match up left, right, up, down, everywhere. They all work together. And if you struggled filling in that table, I would recommend honestly rewinding the video to the beginning of the problem and looking at it again, understanding why the numbers went where they went. Specifically, this 195 and this 125 mess up a lot of students. I have those issues every single year. So if you mess those up, don't feel bad. You're in a good group of students. It's just a lot of people mess them up. They don't think about the 195 being just music and nothing to do with the art. Okay? So now that we have our table figured out, we have one question here. It says, what relative frequency of students that like art also like music? Go ahead and pause the video and answer that question right now. Now, if you remember, this relative frequency is a percentage. So what percentage of students that like art also like music? So students that like art, that's my denominator. Of the students that like art, how many total students like art? 175. That was ugly. Let me try it again. There we go. So of the students that like art, what percent also like music? Well, 100 of them. What fraction? 100 of those 175 also like music. And now that we have the fraction, we can divide this and get our percentage. 100 divided by 175 is 0.571, which is roughly 57%. Okay? Summary. Can you give two pieces of advice for a struggling student on how they can read and interpret two-way frequency tables? What would you tell another student, somebody else who's learning this process, how they can get better? What are some hints you would recommend? Go ahead and pause the video and think about them. Things I would recommend. I would recommend always including a totals row and column on every two-way table. Even if the one's not given, I would make them and make it have those totals because that's very important and it's very helpful. The second thing I would do is when you're trying to find a percentage of a relative frequency, understanding that the of number is your denominator. Of the students that like art, that's the total kids who like art. That's my 175. Or here, of the 8th graders, that was my total 8th graders, those 23 kids. That was the total of them. Okay, those are the two main things I would suggest as hints. There's more you could have said. There's no, by no means those are the only two, but those are the ones that I would come up with. So thank you so much for watching this lesson on two-way frequency tables. Until next time, toodles.